And this slide's encompassing, I guess, the whole of the previous slides. This is a plant in operation. This is equipment that we're using to make our product. So we begin here at time 0, and here's our factor of safety. Everything looks good on paper. No reason we should have a problem here at all. Trouble is, we begin operating the plant. And for some reason, in a localised area, in my little localised small surface area, I get an overload. Then another overload. And that overload could be from operating practices, misalignment, wrong interference fit. There's a whole bunch of reasons that our parts get stressed. And as each part has a stress, we lose a little bit of life. A little bit of life disappears every single time we get to these high points here. Eventually we have so many of these overloads accumulate that the material is now fatigued. It is no longer at the strength it was, it's a reduced strength. Eventually one day comes where the two overlap. The fatigue left in the life left in the part, and the overload it sees on that particular day, she goes down. When it comes to maintenance, what we try and do is find this point here. The point in time where the two curves are not yet overlapping, and replace the part and restart this curve back at the highest value again. So this time here is our part replacement time. It's what we do preventative maintenance for, and we want to fix that date. And if we can get that date right, then we simply renew the part, restart it again, and off we go with, again, much time without problems. If we miss that date, then our curves begin to overlap, and we have more and more breakdowns. Now what it means is eventually every single machine will need to be renewed. Every single part in our machines are suffering up some sort of cycle, some sort of operating loads, some of which are high, some of which are normal. Eventually in time, over the years, they will accumulate. So maybe over 25, 30 years, this scenario typically is going to happen with every machine. So one of the things you want to allow for in your capital expenditure in equipment-based plant is to replace your machines after a certain period of life, because every single part in that machine will be suffering in this situation, and we can't replace all the parts at every single time. So at some point in time, we're going to put a new machine in there and do away with the old machine. But until then, while the old machine's there, we replace the parts that wear out on a regular basis. Now, it doesn't mean we don't have a failure. This particular situation here doesn't mean we have no failure up until that point in time. This is gradual fatiguing by use. We can still have a situation where there's an instantaneous load and bang, she'll fail. That broken gear tooth is an example of, even though it's a brand new machine, still break gear teeth in a brand new machine from a high instantaneous load. So we have this curve down here where this is the machine life. At any point in time, it can see very high stress for whatever reason, and that can cause an instantaneous failure. So some parts will always fail at an unknown time. There will always be some sort of failure from these unknown and unforeseeable high stresses. Eventually, every single part will age, will tire, and so as that part gets older, the chance of failure increases with age. So we get this situation here where even a brand new machine can be failed early because of this unexpected failure load, or eventually every single machine will wear out and have to be replaced. So this curve tells us in time things will fatigue and get old, and up until that time opportunity is always there for things to go wrong. And again, you want to minimise this opportunity. You want to minimise two things: the stresses these parts see and the situations that allow those stresses to arise.